I think I'm audible to all of you, and this PDF is also visible. So in yesterday class, we had already discussed this Lagrange interpolation method, and through this Lagrange interpolation method, we have find one polynomial that best fit this given data, and the desired polynomial is x cube minus 1. But there is a problem with the Lagrange interpolation. Like if you have this data, and with this data you have applied your formula for L0x, L1x, L2x, and L3x. And after all this procedure, you have obtained the polynomial, this x cube minus 1. But if I suddenly have like one more data, like fifth data here, like some 9 and some given data. So it means I have to recalculate again this L0x, because here one more factor in the numerator like x minus x4, and in the denominator like x0 minus x4. So this is the drawback of this Lagrange interpolation method. Like if this you have already calculated for like n data, and suddenly you have added one more data to your data set, then you have to do all the calculation from the beginning. So to overcome this kind of problem, we have another method known as Newton divided difference interpolation formula. So how we calculate this Newton divided difference interpolation formula? First, we define the Newton divided difference. So if you remember, I already defined this. I think this is again visible to you. This one. Okay, this one. So if you remember, like this Wednesday class, then this is your forward difference operator. Like if you apply delta to some function f of xi, what you have to do, fix plus h minus f of xi, where h is the common difference between the equally spaced data. So this is the way we defined our forward difference operator delta. And then backward we have this delta of f of xi. We write like f of xi as it is, and then minus f of xi minus h. Again here h is the like common difference between the two consecutive values of xi. So, but now we are dealing here. We are dealing with the equally spaced, but now we are telling that our data is like unequally spaced. So, for unequally spaced, how we defined our differences? So, for equally spaced data, we have like this delta operator, nabla operator, and then average operator, central difference operator, and shift operator. For unequally spaced data, we have divided difference operator, and this is the definition of divided difference, and this is the notation to represent the divided difference operator, or you can use this notation. I think this is again visible to everyone. Like if we are dealing with the interpolation with the unequal intervals, then also we can calculate differences, for finite differences, but we call this divided difference operator. So how we define this? Like you have x0, x1, xn kind of data, that is n plus 1 data set, and then you define your first order divided difference. So the first order divided difference is defined by this f of x0 comma x1, that is between these two values x0 and x1. And the definition is f of x1 minus f of x0 divided by x1 minus x0. And this notation we use to represent divided difference. Delta cut down by this vertical line. So this delta we use to represent our divided difference operator, and it's a first order divided difference operator. So here this x1 and x naught is telling this us that the way defined, like if delta x1 f of x naught is written here, so it means that f of x1 minus f of x naught divided by x1 minus x naught. If you see the next data, like for f of x1 comma x2, it is defined by this f of x2 minus f of x1 divided by x2 minus x1, and this like cross delta this we call like delta x2 f of x1. It means f of x2 here minus f of x1 divided by x2 minus x1. So if you remember the earlier case, we have equally spaced data, and now we are having unequally spaced data. So here for unequally spaced data, what we are doing, actually we are dividing by the difference between the two values like x0 and x1, so that ultimately the difference of unity comes out. That uniformity, like here also we are dividing from this. So you have to remember these formulas for divided difference. Some author use this notation f big bracket x0 comma x1, and this notation is called the first order divided difference, because here we have only two values x0 and x1, and the definition is f of x1 minus f of x0 divided by x1 minus x0. Or you can use this notation also, cross delta x1 f of x0. Then f of x1 x2 is this one. Like if arguments change, then like f of, because x2 is here, so f of x2 minus f of x1 divided by x2 minus x1. Now we can also define the second order divided difference. For the second order divided difference, we are having three variable like x0, x2, x1. And first we write the first order divided difference of these two variables, you can see here. And then we minus the first order divided difference of these two, that is this one. And then divided by the last argument minus the first argument, like x2 minus x0. So this is second order divided difference formula for the case of three variable x0, x1, x2. So this, if a one variable increase, that means it is a second order divided difference and denoted by this one. And some author use this delta x1, x2, x0, f of x0. So it like this. Then f of x1, x2, x3, if you are calculating for next three data, because you are having with you n plus 1 data points, so you have to obtain divided difference for next three data also, like x1, x2, x3. So here again, first you write the first order divided difference of these two, then first order divided difference of these two divided by the last argument minus first argument x3 minus x1. Similarly, we have third order divided difference formula. I think it is visible again to everyone. So this is third order divided difference. So here we have four arguments, you can see. And then we define like second order of these three, like f of x1, x2, x3, and then minus second order of first three divided difference, and then last argument minus first argument, or x3 minus x0, or like this x1, x2, x3, x0, f of x0. So this is the way we defined our first order. This is the notation, not the like we can interpret as a function also, but it's a notation to represent the second order divided difference, the third order divided difference, and in general you can define the nth order divided difference also like this. So like you can see here already, like here to calculate the third order divided difference, I require the second order divided difference, these two. So I will substitute the value of this from here. And then in this I require this one. So I substitute this value from here. And then now I am having with me like f of x2, f of x1, x2 minus x1. So finally I can calculate this third order divided difference of x0, x1, x2, x3. So we will see some like how we construct the table for it. Like this is the data given to us. X is 4, 5, 7, 10, 11, 13. And the corresponding f of x values are this one. And then you have to construct the divided difference table. So like if you remember the difference table, here the third column for first forward difference, but as the data is unequally spaced, you can see 5 minus 4 is 1, and 7 minus 5 is 2, and 11 minus 10 is again 1. So these are not equally spaced. So we cannot calculate the forward difference table. So we have to calculate like a divided difference table. And the divided difference table, like between these two values, x0 and x1. So you know that the formula is f of x1 minus f of x0 divided by x1 minus x0. So what is f of x1? 100 minus 48. 100 minus 48 divided by 5 minus 4. And finally, this is your answer, 52. Then 294 minus 100 divided by 7 minus 5, it is 97. So it is the like first divided difference of x1, x2. First divided difference of x2, x3, it means this minus this divided by 10 minus 7, this is. So like this you can calculate the first order. Now you can to calculate the second order, what we do, because we know that in the second order difference we require the first order differences of last two, and then minus first order difference of first two variable. So here we have three variable x0, x1, x2. So it means 97 minus 52, this, and divided by the third value, this x7 minus this. So like you can diagonally go to like this, 7 and minus 4. So like this you have to go. So this 97 minus 52 by 7 minus 4. So you will get the second order divided difference. To get this one, 202 minus 97, and then divided by this 10 minus 5, because this is actually from this and this. So 202 divided minus 97 divided by 10 minus 5. And similarly you can calculate the other second order differences. Now to calculate the third order divided differences, so you like this minus this. Now you have actually with you four variable x0, x1, x2, x3. So four arguments you are having with you. So 21 minus 5, and you know that this actually going this way, and this one like last minus this x3 minus x0. So you will get this one. So this is the divided difference, and similarly you can calculate higher order also. So this is the way we construct our divided difference table. Okay. So I think this is again visible to all of you. So the divided difference, we have the data, this xi, f of xi, that is we are having with us n plus 1 data points, and we define the divided difference as follows, like for two values xi and xi plus 1. So f of xi plus 1 means this is xi plus 1, so f of xi plus 1, f of xi plus 1 minus f of xi divided by xi plus 1 minus fxi. So this is our first order divided difference. This notation, because it's contain only two argument xi and xi plus 1, so it is a first order. So in particular, if I substitute I equals to 0, f of x naught comma x1 is f of x1 minus f of x naught divided by x1 minus x naught. Similarly, f of x1 minus f divided difference of these two values x1 x2 is f of x2 minus f of x1 divided by x2 minus x1. And we can also rewrite like this, that they are like commutative in terms of variable. Like if we change the order of variable xi minus xi plus 1 and xi plus 1 xi, it will give us the same result. But it's better not to change this order. So you remember this in this form: f of xi plus 1 minus f of xi divided by xi plus 1 minus xi. Now the second order like means three argument xi plus 1 xi plus 2. So like first we have divided first order divided difference of these two, you can see here in the numerator, and then divided difference of first two xi and xi plus 1, and then the third argument minus first argument xi plus 2 minus xi. So in particular for these three values, f of x1 x2 minus f of x naught x1 upon x2 minus x1. So to like simplify this one, f of x naught x1 x2, this has to be taken out, like 1 upon x2 minus x naught is already out, and then we have used the definition of this f of x1 x2, f of x1 x2, you know that this is this one. And here instead of x2 he has written the f2. So I already told you the notation. Wherever f2 means f of x2, and f1 means f of x1 upon x2 minus x naught. सॉरी ये यहाँ पे गलत है, x1 होना चाहिए, f2 minus f1 upon x2 minus x1, as here it is 1, so here it should be 1, and f1 minus f naught upon x1 minus x naught. Then you multiply this term inside, like if x naught minus x2 go inside to this term, then like first he is written for f of naught, so we can see that there is only one term containing the f naught. So f naught upon x1 minus x naught is there, and then x naught minus x2, the minus is adjusted. So this minus adjusted this, and this minus and this two common, and then they revert it, and then finally we have this f naught upon x naught minus x1, x naught minus x2. f1 is having two terms, one is having in the denominator x2 minus x1, and another one is x1 minus x naught, and one is x2 minus x1. So x2 minus x1 term is here, and multiplied by this x2 minus x naught, f1 is outside. Similarly, x naught minus x1 minus x naught, and this minus is taken out here, because this one f1 is also minus, and this f1 is also, and similarly like this. And you simplify or adjust these minus, you will have this form of the divided difference. Some people remember this kind of form of divided difference: f of x naught divided by x naught minus x1, x naught minus x2, f1 of x1 upon x1 minus x2, x1 minus x1 minus x naught, x1 minus x2, and f2 upon x2 minus x naught, and x2 minus x1. So this is the second order divided difference. So they write like this. So in general, like you have like I in like three variables like xi plus 1, xi plus 2. So you know that the second order defined in terms of the first order divided difference, f of xi plus 1 comma xi plus 2 minus f of xi comma xi plus 1 divided by xi plus 2 minus xi. And then whatever some calculation done here, we can done for this also, and finally have this one. So you can see this f of xi plus 1, xi plus 2 can be rewritten as the divided second order divided difference is f of xi comma xi plus 1, xi minus xi plus 2, then f of xi plus 1, xi plus 1 minus xi plus 1 minus xi plus 2, f of xi plus 2, f of x upon xi plus 2 minus xi, and xi plus 2 minus xi plus 1. So in general, the nth order divided difference is defined like this. And then you go in the recursive manner, like f of x naught, x1, xn is, because here we are having n plus 1 argument, and it means if we are having n plus 1 argument, it is nth order divided difference. And to calculate this one, we calculate the first the n minus 1th order divided difference of these variable. This is the n minus 1th order divided difference of these last n variables, and this is the divided difference n minus 1th order divided difference of this first n variables, and divided by xn minus x naught. So this is the in general nth order divided difference. So this is the way we write its divided difference table, like x naught, f naught. This is the given data with us, and the first divided difference is like f1 minus f naught divided by x1 minus x naught, and it is actually f of x naught comma x1. Similarly, these can be done. Now to calculate the second order divided difference, it means this one is equals to this f of x1 comma x2 minus f of x naught comma x1 divided by x2 minus x naught, and like this. So these are the some problem you can try yourself. So here we have to calculate the table for the divided difference minus 1 minus 8 0 3 2 3. So you can see already that they are not equally spaced in terms of x. So we have, if we want to construct difference table, so we can construct only the divided difference table. So we have rewritten the data like x and fx like this, and then use the definition of first order divided difference. So 3 minus 8, 3 of minus 8 minus plus 8 divided by 0 minus 1. So this is the first order divided difference between these two values. First order divided difference between these two values means 1 minus 3 divided by 2 minus 0, that is minus 1, and 3 this minus this divided by 3 minus 2. Similarly, you can calculate second order divided difference like this minus this divided by 2 minus of 1, and 11 minus of minus 1, it means 3 minus 0, you have this one, and the third order divided difference is 3 minus of minus 1, and you have this one, 4 minus 4 plus 4 divided by 3 minus 1. So this is the third order divided difference. There is a theorem I will prove later. Like if you are having n plus 1 data points, so n plus 1 data points means here n is 3, because it's a 4 data set. So n is 3. It means your third order divided difference can be non-zero, but fourth and higher order divided difference, but fourth and higher order divided difference are always 0. So if you are having with you n plus 1 data set, it means your nth divided difference may or may not be 0, but higher order like n plus 1th and higher order divided difference are always 0. So this theorem we will prove. So now we go to the concept of Newton divided difference interpolation. So we have taken the interpolating for polynomial for Newton divided difference like this: Pnx equals to C naught x minus x naught C1 x minus x naught x minus x1 C2, and like this. So you can see here that it is like a nth degree polynomial, because here we are having n minus 1 n terms. So it's a n degree polynomial, and we will calculate this C naught, C1, C2, and Cn, so that they satisfy the interpolating condition, this one. The polynomial at xi should be equal to the function value at xi, and we calculate all these values and substitute the values of C naught, C1, C2, Cn in this, and we get the desired formula. So we'll start from this x naught. So if I substitute x equals to x naught on the both side of equation 2.15, in the left hand side I will get f of x naught, and in the right you can see that x minus x naught. X minus x naught factor is common to all these highlighted terms. So if x minus x naught is a common factor to all these highlighted terms, it means when I substitute x equals to x naught, these all are 0. So in the right hand side I will get x c naught, and in the left hand side I will get f of x naught, and f of, because p of x naught is actually f of x naught, so c naught value is actually f of x naught, and f of x naught are given to us. It's a given value, f of x naught. Now to calculate this x1 c1, I substitute replace x by x1. So Pn of x1, it means I know that these term, all of these terms contain x1, so all these are 0. These two terms remaining with us. So C naught plus x1 minus x naught into C1, and in the left hand side we have Pn of x1, but as per interpolating condition, Pn of x1 is should be equals to f of 1, so it is f of 1. C naught I already calculated in the previous step, so I will substitute the value of C naught here, and I will get the value of C1. So first like this C naught taken to the other side, and then divided by this x1 minus x naught, so f1 minus C naught upon x1 minus x naught, and finally f1 minus f naught upon x1 minus x naught. This is C1. And this is, if you remember the definition of divided difference, this is the first order divided difference of x naught and x1. So the C naught is f of x naught itself, and C1 is the first order divided difference of x naught and x1. Now to calculate C2, again I substitute x equals to x2 in this formula. So these three term will be remain, and other term contain the factor x minus x2, so other terms are 0. So in the right side we are having this one, C naught plus x naught, x2 minus x naught C1, x2 minus x naught, x2 minus x1 C2, and in the left we have Pn of x2, but Pn of x2 is by interpolating condition, it is f of x2, so this one. And after simplification and substituting the value of C1, C1 is f of x naught, divided difference of x naught and x1, so we have substituted this one, and C naught is actually our f of x naught, and finally we have this one. After more simplification you have this one, and finally you have this one. And we have already proved this, that this form is actually telling us this is the second order divided difference of x naught, x1, x2. That like all CIs can be calculated in terms of the divided difference. So Cn is nth order divided difference of x naught, x1, x2, xn. And if you substitute all the values of C naught, C1, C2, Cn in the equation 2.5, you will get your interpolating polynomial Pnx. So Pnx equals to C naught is f of x naught, x minus x naught is there, f of C1 is f of x naught x1, first order divided difference. C2 is f of x naught comma x1 x2, second order divided difference. And Cn is nth order divided difference of these n plus 1 values. And this formula is known as Newton divided difference interpolating formula. Sometimes in Viva I directly ask state the Newton divided difference interpolation formula, so you have to like explain me in this way. Okay, so we'll see some problem. So find the value of fx. Find fx as a polynomial in x for the polynomial data by the Newton divided difference formula, this one. So this is x and this is f of x. So first, even though in exam I specifically mentioned the method name, but like you, if somewhere you get this kind of problem, then you have to check whether it is equally spaced or unequally spaced. If it is equally spaced, then there are easy method to find the interpolating polynomial. But here it is unequally spaced. One can easily see that the difference between n all consecutive values of x are not equal. So I have to find a polynomial that fits this data. Even though you can try or use your Lagrange interpolation method also to solve this or to fit the polynomial to this data. But if in exam I told you to solve with the help of a Newton divided difference, then you have to apply this procedure. So the divided difference formula is this one. F of x equals to f of x naught plus x minus x naught, f of x naught, this, the formula. So you know that in this formula, I know f of x naught because this is x naught, so this is f of x naught. So f of x naught I am having with me. X naught also I am having with me. X1, x2, x3, all three are here. But the problem is that these divided difference I am not having. F of x naught x1, f of x naught x1 x2, f of x naught x1 x2 x3. These divided difference I am not having with me. So to calculate this divided difference, I construct the this divided difference table. So first I construct the divided difference table. So this is the x values given, and this is the f of x values given. And this is x naught, x1, x2, x3, x4. This is f of x naught, f of x1, f of x2, f of x3, f of x4. And then you have to calculate the first order divided difference. If you remember, the formula is 33 minus 1245 divided by minus 1 minus 4, that is 3, and you will get minus 404. This minus this divided by 0 minus 1, you will get minus 28. 9 minus 5, 9 minus 5 is 4, and 4 is divided by 2 minus 0, that is 2. So 4 by 2 is 2. Similarly, 1335 minus 9 divided by 5 minus 2, that is 3. You will get 442. To get the second order, so here in the divided difference table also, these values are important to us. These values we have to substitute in our Newton divided difference interpolation formula. So minus 28 minus of 404 divided by 0 minus 4, that is by 4, you will get 94. This minus this, it means 30 divided by 2 minus of minus 1 by 3, you will get 10. And 442 minus 2 divided by 5, you will get 88. And this is the second order divided difference. Then again 10 minus 94, 10 minus 94 is 84, and 84 is divided by 2, minus of minus 4, it's 6. So 84 is divided by 6, you will get minus 14. Then 88 minus 10, that is like 78, divided by this 5 minus minus 1, 6, you will get 13. And then 13 minus 14, 13 minus 14 is 27. 13 minus of minus 14 is 27, and 27 divided by 5 minus of minus 4, that is 9, you will get 3. So this is the f of x naught. This is f of x naught x1. This is f of x naught x1 x2, f of x naught x1 x2 x3, f of x naught x1 x2 x3 x4. So this is first f of x naught, first order divided difference between first two values, second order divided difference between first three values, and third order divided difference between first two values, second order divided difference between first three values, and third order divided difference between first three values. So f of x naught is as it is, 12, 4, 5. And then the first term is x minus x naught. So x naught is minus 4. So x minus x naught, it is x plus 4. So like this. And first divided difference between x naught and x1, which is this one. Then the second term is x minus x naught into x minus x1. X minus x naught means x plus 4, and x minus x1 is x plus 1, because x1 is again minus 1, so it should be x plus 1. And the second order divided difference between x naught x1 x2, that is 94, this one. Then the third term is x minus x naught x minus x1 x minus x2 into this, the third divided difference. And the fourth term is x minus x naught x minus x1 x minus x2 x minus x3 into fourth order divided difference, this one. And you simplify all these, and finally this is your interpolating polynomial. So you try all these example, like some example like this, they have told you to find the derivative of f dash 3. So once you have obtained using your Newton divided difference formula the corresponding polynomial, you differentiate that polynomial and put x equals to 3, you will get this. And if you differentiate 2 times, you will get this one. Like this is the interpolating polynomial, this one. So one time differentiation will give this one, and second time differentiation will give this one, and then you substitute 3 and 1.5, you will have this. So there is another problem of inverse interpolation. Like if y values are given to you, how you calculate x values, this we will discuss in later classes. Now we discuss the interpolation with the equally spaced data. And for equally spaced data, we have already introduced these shift operator E. Whenever it applied to any variable, it will like f of xi plus h. So equally spaced data means the common difference between two consecutive values of x, or the all values can be generated by this formula, xi equals to x naught plus ih, because h is the common difference. So x1 is like x naught plus h, x2 is x naught plus 2h. So like this, and I'm not going to repeat this one because the shift operator already discussed. This one is also discussed. Forward difference operator is also discussed. Second order, third order, the relation is also okay. This is actually one good result. Like if you want to calculate the nth order forward difference at any point value xi, So you can replace this delta by its equivalent operator like this, e minus 1, because we have already proved that the relation between the shift and delta operator is e minus 1. And then you write e minus 1 raised to power n. And then you apply the binomial expansion on this part. You will get this one. And then you apply f of xi to this expression, and you will get this kind of expression. So you will see the application of this one also. Then the backward difference is already discussed with you, second order also. And the relation between the backward and inverse shift operator is this one. And so we can also calculate the nth order divided difference of a function at any point f of xi, like substituting the related equivalent of nebula is 1 upon 1 minus e raised to power minus 1 raised to power n. Then I again use the binomial expansion and then apply this to the right. I will get this kind of expression. So we'll use this one to find the missing value from the table. This how we construct the divided backward difference table, like this minus this, just interpretation is changed, this minus this. So you can see that here is nothing is in the division because the data is equally spaced. So we get these kind of values easily. Similarly, forward difference table, this minus this again, but the interpretation is first forward of f of x naught. This minus this, interpretation is first forward of f of x naught. So like this. And this is already discussed in earlier classes. So here they have constructed the forward difference table. So this is the data. This is corresponding fx values. So this minus this simply give you first order difference of fx. And this minus this minus 2, and this minus this 11, again this minus this one, this minus this is this one. And these values are important to us when we are dealing with forward difference formulas. And this is for backward difference. You can see the same data is here. Whatever data we have here in the forward, minus 8, 3, 1, 12, in the same data we are having here, and the values are also getting the same, 11 minus 2, 11, but the interpretation is changed. Now it is delta of nebula of f, and now in this case these values are important to us, this one, because this is a backward difference table. Then this is central difference, so we'll discuss all this. Okay. Okay, this is actually, I'm searching for Newton forward difference interpolating formula. So you have to remember, like when I write Newton divided difference interpolation formula, it is for unequally spaced data. And when I write Newton forward difference formula, then it is means if we are dealing with the equally spaced data. So if h is the common difference between two consecutive values of x, so we know that whether the values are equally spaced or unequally spaced, the divided difference formula are always applicable because they are not depending on the difference. So the formula is like this one. If you remember, this is the Newton divided difference interpolation formula we used in today class. F of x equals to f of x naught plus x minus x naught. First divided difference of x naught, x1, x minus x naught, x minus x1, f of x naught, x1, x2, x. So the two formula, Lagrange interpolation and Newton divided difference interpolation formula, can be applied to both kind of data. because their creation is such that they are not their development is not depending on the difference of the two consecutive values. So we will prove the relation between the divided difference of nth order. You can see that this is the divided difference of x naught, x1, xn of nth order, and this is the forward difference of nth order. So we will prove this relation, and then we replace everywhere by this, and we will get the Newton forward interpolation formula. They have not given the proof. Okay, here actually they have given about this. The proof is here. So this is the if you remember the divided difference formula. The divided difference formula xi and xi plus 1 is this one. F of xi plus 1 minus f of xi divided by xi plus 1 minus xi. But we know that now we are dealing with equally spaced data. So for equally spaced data, the difference between the two consecutive values is h. So I have written 1 by h. And the numerator, I know that this is the definition of forward difference, because forward difference of f of xi is f of xi plus h minus f of xi. So that means the first order divided difference, if we are calculating for equal data, it will be 1 upon h. First order 1 upon h, first order divided difference of f of xi. In terms of backward, 1 upon h, backward of f of xi plus 1. Now for the second order divided difference, you can see this can be, by the definition of divided difference, it is first order divided difference of these two minus first order divided difference of these two, and then divided by xi plus 2 minus xi. So this and this. So here, first this denominator term you can see, because it is xi plus 2 minus xi, so it means there are two difference of h between xi plus 2 and xi, as we are now dealing with equally spaced data. So xi plus 2 is minus xi is 2h. Now we come to this f xi comma xi plus 1. So f of xi comma xi plus we have already calculated, and this one is 1 upon h delta of f of xi. Now we have this term only, f of xi plus 1 comma xi plus 2. So when to calculate this highlighted area, if I replace I by I plus 1 in this, if I replace I plus I by I plus 1 in this, I will get 1 upon h delta of f of xi plus 1. So it means this one is equals to 1 upon h delta of f of xi plus 1, because I have replaced I by I plus 1 in this formula. So finally we are having with us this one. Now this 1 upon h is outside. So like 1 upon h square, like this. And again in the numerator I am having first forward of f of xi plus h minus first forward of f of xi. And I know that it is actually second forward of fxi, or you can calculate, take common this delta outside. So inside you have f of xi plus h minus f of xi, and f of xi plus h minus f of xi is delta of f of xi, and one delta is outside, so it is delta 2 times of f of xi plus h. So it means if you are calculating the divided difference of second order for equally spaced data, it is actually equal to this one, 1 upon 2 factorial h square second forward of f of xi. So in general, the divided difference of nth order divided difference is equal, if it is calculated for equally spaced values, you will get 1 upon n factorial h raised to power n nth forward difference of f of x. So I substitute all these values, this equivalent to, in the Newton divided difference interpolation formula, and I will get this f of x naught x minus x naught delta of f of x naught divided by 1 factorial into h, यहाँ पे plus missing here, 1 plus is missing here, x minus x naught, x minus x1, delta 2 f of x naught upon 2 factorial into h square, and like this. So this is called the Newton forward difference interpolation formula that we will use for equally spaced data. So to use this, what we do, we do some more simplifications, because we know that the value of x is x naught plus sh. So if we want to interpolate near the point x naught, so we set like x equals to x plus hs. Like the value, the unknown variable, na, x, for this unknown value of x, we are trying to get the value of fx. So if I am supposing the new value of x is actually x naught plus some real value s into h, and this can all be, we can assume this, like maybe s is a fractional minus or something, but we will get some s like that, so that nex can be equals to x naught plus sh. So if I substitute this x naught plus sh in this formula, so what I will get, first, what is the value of x minus xi? I know that x is x naught plus sh, I assumed, because we can always find s such that x naught plus sh equals to x. So this is this one. And xi, from the definition of xi, it is x naught plus ih. And then you can see x naught will cancel out, and you have s minus I into h. And then x minus x naught is equals to, so in general, like for x minus xi, this is x s minus I up into h. So if instead of xi I replace by x naught, it means by 0 here. So x minus x naught is sh, x minus x1 is s minus 1 into h, x minus x2 is s minus 2 into h. So I, wherever I am having x minus x naught, x minus x1, these kind of terms, I replaced by s minus 1 into h, s minus 1 into s minus 2 into h, like this. So I am getting this formula. So f of x naught plus s delta of f of x naught plus s into s minus 1. So you can see now this h is not here, because x minus x naught is s into h, but 1h is already in this factor in the denominator. So when this h goes to the numerator, in the, when we replace this x minus x naught by sh, so the numerator h will cancel out this denominator h. Similarly here, we get 2h, 1h from this s minus 1h, and 1h from this s minus 2h. So we will get 2h, that is h square in the numerator, and 1h, h square in the denominator is already present, so we will cancel out. So you have this one, f of x naught plus s delta of f of x naught plus s into s minus 1 upon 2 factorial delta 2 of fx naught s into s minus 1, s minus 2, s minus, and sometimes we write in bracketed form minus of n minus 1 or minus n plus 1. And this can be rewritten as sc2, if you remember the combination, and sc1, sc0, s upar, the notation is like this, is a combination. So sc naught, sc1, and scn. So the formula is this one. So we will see one problem. Okay. So we have this data. So when we are using this forward difference interpolating formula, first we check the whether the values are equally spaced or not. You can see the common difference between two values is 1. So it means it's a equally spaced data. So we'll construct its corresponding difference table. This is the table. So this minus this is minus 10, this minus 5 minus 4, minus 4 minus 10 6, 6 minus 6 0. So it means your third order differences are turns out to be zero. If your third order forward differences are zero, it means it's all higher orders are zero, because next you are going to this minus this, na? So it is zero. So it means when you are writing your Newton forward interpolation formula, you will write the formula wherever is this second order differences of x naught is occur, because third and higher order differences for this particular data are turned out to be zero. So this is the Newton forward interpolation formula, because the third and higher order third and higher order terms containing this higher order forward differences are zero, so they are not included here. And then you substitute the values. So f of x naught is this one, means x plus 2, and delta, actually ये notation भी गलत लिया है book में. This notation is also wrong in this book. He is writing forward difference, so he has to write delta in place of nebula. So when you are preparing your notes, you take care of this. This should be delta, not nebula. This is wrongly printed in the book. Okay. So this is delta of f of x naught is minus 10. Delta 2 of f of x naught is 6, and others are 0. You substitute all this. So you can see that for equally spaced data, it is easy to find the interpolating polynomial. This is the polynomial, and the value of f at 0.5 is asked here. So
एक्टिविटीज को बनाने के लिए हमारे पास पैकेज के ऊपर हम लोग रहते
What happened, Jagdev?
न्यू
Jagdev, mute.
एम्प्टी एक्टिविटी,
Hello,
और
Jagdev.
यहाँ पे एक्टिविटी का
Yes, sir. Yes, sir. Sorry, sir.
Okay. Okay, I think I have to stop here. So I will submit a assignment, or I will give you an assignment related to this topic by today evening or tomorrow, and then on the this next is. So the test will be on 8th. Is okay, or is there any problem?
Sir, you have previously told about the assignment you will give on the topics you covered, but it's not till now.
Okay, I will give all those.
Yes, sir. Yes, sir. That will be revision before the test also.
And that is actually required, na? What kind of question in the exam? You have a
Yes,
little bit
yes, sir.
idea.
Yes, sir. So I told you that assignment.
Okay, I will give you. Okay, next thing is that text, your class test will be on 9th, na? Instead of 8. Is there any problem to anyone? If the class test is on 9th of September. So no problem, na? So the class test in the class timing 9 to 10 on 9th, and I will search the assignment, and I will give you the assignment question also. And you have, if any difficulty, you can post the question in WhatsApp, and I will reply to that. And it's a 10-mark question, and it is not objective like earlier, it's subjective one. And today you should give your attendance also. So you post your roll number in the this meet chat. Like roll number 1, if you are present, write 1.